Here's a device you used in Lab 9. Let's do a quick review. At this end of the tube is an electron gun that accelerates a beam of electrons straight to the bottom of the tube right here. Later on in this video, I'll be waving this bar magnet around and we'll see what happens to the deflection of the beam. But back to the device. You see on the device there are two coils. The coils are set up so that when current is going in this direction in one coil, it's also going in the same direction in the other coil. If current's going this way in this coil, then the current goes this way in the second coil. So let's assume that the current is going in this direction in this coil. Using the right-hand rule, we point our thumb in the direction of the current and we wrap our fingers around, and in this vicinity, the magnetic field created by this coil is pointing towards you, towards the camera. We can do the same thing for this coil, and again, using right-hand rule, the magnetic field is pointing in this direction. So these coils are set up in an arrangement called a Helmholtz pair. What that does is create a very uniform magnetic field in this vicinity, in the region where the electron beam is moving. Let me turn down the lights so you can see the beam. I'll bring the end of the bar magnet in, and you can see that as I move this magnet around, the beam is doing some really funny things. It's really kind of cool. It looks like Aurora Borealis. It's really cool. Okay, so let's not deflect the beam with a permanent magnet, but let's instead deflect the beam by putting current through the Helmholtz coils. So as I turn up the current, you can see that beam start to deflect until pretty soon the beam clears the bulb and makes a full circle around the tube. As I make the magnetic field stronger, the beam gets smaller and smaller. You need to figure out what the direction of the magnetic field created by these coils is, and the direction of the current in these coils. Now I'm decreasing the current, and the beam gets bigger. If I increase the accelerating potential, the beam gets smaller. As I decrease the accelerating potential, the beam gets bigger.